We are moving on to 6.4. So the material in this will not actually be on your quiz. Your quiz is going to be over section 6.1 to 6.3. This is additional information on similarity that you'll need to know for your test, and it'll be beneficial for you to know this also. It just gives you more information before you take that quiz. Okay, so what we are talking about is angle-angle similarity. So in the past sections, we talked about similar figures. They have to have all equal angle measures, and then all their side lengths have to be proportional, okay? In this postulate, what this is saying is that if we know two angles are congruent to two angles on another, okay, sorry about that, guys. Two angles on another triangle, then the two triangles are similar. Now, we learned, I believe in last unit, that if you know that two angles on this triangle are congruent to two angles on this triangle, by third angle's theorem, we know that the third angle is also congruent. So because we know that two angles are congruent, we actually really know three angles are congruent, which makes the two triangles similar, okay? So this is a postulate that will prove similarity. If we think back to congruent triangles, remember we had like side, angle, angle, hypotenuse, leg, which one am I missing? Side, 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 and angle, angle, side. Those were all, those 5 ways were how we proved triangles are congruent to one another. Remember that one of the ways that didn't work was angle, angle, angle. But here, essentially, angle, angle does work for similarity. It does not work for congruent. Okay? Determine whether the triangles are similar. If they are, write a similarity statement. So if this angle is congruent to this angle, but then if we remember, vertical angles are also congruent. So similarity statement would be triangle. I'm going to start with the smaller guy, and I'm just going to, order does not matter on that one. So I'm just going to say triangle A to B to C is similar to triangle. Okay, what matches up with A? A is the one that doesn't have any markings, so that has to match up with E. B is the one with 2, so it has to match up with D, and C matches up with C because they both have one arc. Go ahead and pause me and see if you can do 2 through 8, deciding whether the two triangles in the figure are similar or not, and if they are, write the similarity statement. If they're not, of course, you don't need to write a similarity statement. Okay, so we have 35, 35, this is 65, and this is 85. What I would need to do is I need to figure out how many degrees R is. So 180 degrees in a triangle minus the 35 they gave us minus the 85 that they gave us. That leaves me with 60 here. If this is 35, this is 65, I can do 180 minus 35 minus 65, and that is 80. So we do not have two angles that are similar, so these are not similar. On this one, we have this top triangle, right? But then we also have this large triangle. Angle J is on both those triangles, so it is congruent to itself. This is parallel to this by that marking, which means that corresponding angles are congruent. And this is a corresponding angle to this guy, so those would be congruent, okay? So we have at least 2, we actually have 3 similar or congruent angles. So triangle J to K to N is similar to triangle J to L to M. I'm just going off the markings, right? Here we have a triangle here, and we have a big triangle. So this angle is congruent to itself. So this angle P is on both triangles. So 50 degrees on the big triangle, 50 degrees on the small triangle. We have an angle that's 45 degrees on the small triangle. We have an angle that's 85 degrees on the big triangle. So I'm going to figure out what S is and what T is. So T would be the 180 minus the 50 minus the 45, which would be 85 degrees. So now we have 2 angles that are congruent. That would leave 45 for this guy. So they are similar. So triangle P to Q to T is similar to triangle. So P was my 50 degrees on the small one. It's my 50 degrees on the big one. Q was my 45 degrees, so it matches up with S, my 45. And T is my 85, so that matches up with R, my 85 on that guy. Next problem, we have a triangle here and we have a triangle here. 65 and 65 match up. They both share angle C, so those are congruent. So they are similar. So triangle, let's start with the small one. C to B to D is similar to triangle. C matches up with C, B matches up with A, D matches up with E. If you did these in a different order than me, that is fine. Just make sure that these letters match up, that D goes with E, B with A, and C with C. This one, okay, if I look here, these do not have the same markings, but what this is saying is all three of these angles are congruent. Well, if all three angles are congruent and we have 180 degrees, that would mean 60 degrees for each angle. Same thing here. All three angles are congruent to one another. They have to take 180 divided by 3, 60 degrees. So they actually end up being similar. So triangle FGH is similar to triangle. Now, on this one, it doesn't matter order. So QRS. Okay? Because I could flip this and it's going to be 60 degrees and similar. This one down here, I actually have 1, 2, but then I have also a third big triangle. Okay? This is 90, and that's 90. Let's figure out, so 180 minus 90 minus 58 leaves me with 32. So they are similar, so this has to be 58. So I would have triangle, let's start with F to D to C is similar to triangle F matches up with F. D is the 58 degree one, so that would be E. And C is 32, that matches up with D, 32. But we also have a big triangle here. And actually, this big triangle is similar to those small triangles because we have a 32, 58, and that adds to 90. So I could also say it's also similar to triangle. So F was my 90, so that would be D on the big one. D was my 32, so that's C on this one, so we're left with E as the last letter. And then the last one, these two things are parallel and is congruent to itself. We have one triangle and then the big triangle. This is congruent to this by corresponding angles. So I have triangle NMP similar to triangle NLQ. All right, next page. Is it possible for JKL and XYZ to be similar? So we have this triangle, J to K to L, X to Y to Z. J is 71, K is 52, X is 71, Z is 57. So really I need to see how many degrees Y is or L to see if they match up and have the two angles. So I'm going to do the 180 for a triangle, minus the 71 here, minus the 52. And I'm left with 57. So then they do have two angles that are congruent, and which would make this third angle congruent also. So this would be yes, by, angle, angle. JKL is a right triangle. So J to K. Oop, we don't know where that right angle is. And XYZ is a right triangle. Well, we're going to say that they add to 150. So this could be 90 degrees, and this could be 60 degrees possibly. This could be my right angle down here. So this is a right triangle, and then we know this. Is it possible? Yes, it's possible. It doesn't have to be. So yes, possible. It doesn't have to be. So the only thing they're telling me about X and Y is that they add up to 150. So I could have a triangle here, and this be 70 degrees, and this be 80 degrees, and that adds up to 150 also. So that it doesn't have to be 90, and so that's why I'm saying yes, it's possible, but it doesn't have to be. This one, angle J is 87, and angle Y, that's all we know. So yes, that's possible again. Oh, wait, maybe not. Let's try this. J, K, L, X, Y, Z. We know J is 87. We know Y is 94. In order for these two to be similar, this would have to be 94 also. So it's 94 plus 87. 181. So those two together make 181, which is more than what a triangle holds. So this is not possible, because these two angles, for them to be congruent, I would have to have the same angle here and here. And that adds up to more than 180, and 180 is how many degrees are in a triangle. So that does not work. Next one, a flag cast. So problems like this, guys, you really need to make sure that you're drawing the picture, okay? So we have a flagpole. It casts a shadow that's 50 feet long. So that's 50 feet. We also have a woman standing here who is 5 feet 4 inches. Shadow is 40 inches long. Okay? How tall is the flagpole to the nearest foot? We're going to take 5'4" and we're going to change that into, not a decimal, but we're going to change it into inches because it's, as a decimal, it'd be 5 divided by 12, which is, or I'm sorry, it'd be 4 over 12 because there's 12 inches in a foot. So it's not just 5.4, it's 0.3 repeating. So we're going to just change it into inches because this is also inches. So a foot has 12 inches, so 12 times 5 is 60, plus that 4 extra, so that'd be 64 inches. So we're going to set up a proportion here. We want to know how tall the flagpole is, so the flagpole is x over 50. We can leave this as feet, and it'll give us as feet here, as long as these two have the same units. So x is the height of the flagpole. That matches up with the height of the human. 50 is the length of the shadow, which matches up with the length of the shadow here. So now I'm going to cross multiply. So I'm going to do 64 times 50, 3,200, sorry, equals 40x. I'm going to divide by 40. And we get x equals 80. And that is in feet, because the 50 was in feet. And that makes sense for a height of a flagpole. An air hockey player, Dave, returns the puck to his opponent by bouncing the puck off the wall of the table as shown. From physics, the angles of the path of the puck makes with the wall are congruent. What is the distance d between the puck and the wall when Dave returns it? So we're right here. So if you notice, we have two similar triangles. This is 26, this is 20. This we don't know, we have to find, but we could find from here to here because we do 66 minus 26, which gives us 40. So now I can set up a proportion. I can do 20 over 26, so side over bottom equals d over 40. Now, there are a whole bunch of different ways to set up proportions. Excuse me. So this is not the only way that you have to set up this proportion, okay? To check to make sure that your way works, make sure that the numbers diagonal from one another are the same. So like I have 20 and 40 diagonal from one another, you should have 20 and 40 diagonal from one another. Same thing here. So when I cross multiply, I get 26d equals 800. I'm going to divide by 26, divide by 26. I'm going to do 800 divided by 26. And I get d equals 30 says to the nearest hundredth, that's 2 decimals. So 77, because it's actually 30.769. That 9 makes that 6 go up when we round. What's the total distance the puck traveled in its return? Well, it's traveling this. Those are right triangles, and we don't know those side lengths. But we can use Pythagorean Theorem to find those side lengths. So I could do 20 squared plus 26 squared equals x squared. So 20 squared is 400. 26 squared is 676. So I'm going to add 400 plus 676, and I'm going to square root that answer. So we get x equals 32.80. Okay? I'm going to do the same thing for y. I'm going to do 40 squared plus, we're going to do 30.77 squared equals y squared. So 40 squared plus 30.77 squared. It gives me a number about 2,546, and then I'm going to second square root that answer, and I get y is 50.47, rounded correctly. So now I'm going to add those two things. I'm going to do 32.8 plus 50.47. I'm going to add those. We'll get 83.27 inches is how far away. All right, hopefully that made sense. You do have a homework assignment over this. make sure that you have done the review and all the homework assignments up into the quiz. And then Wednesday, you need to take that quiz. It'll be open from 8 a.m. to 8 p.m. Thanks, guys.